so today's lesson is over addition and subtraction of radicals. This is really easy, you guys. So first off, we do have a couple of rules that you are going to want to jot down. So rule number one, and yes, you guys are taking notes on this. Don't just sit there staring at the video. Write down all the problems we're solving here. You should be solving them with me, writing down the steps. We'll get to some guided practice at the end in which I'll put the problem on the board, pause it, you guys pause it for a second and solve it, just to make sure you understood. So, first rule, whenever you're adding and subtracting radicals, you are only adding and subtracting the numbers that are outside of the radical. You're never going to add or subtract the numbers that are on the inside, only the numbers on the outsides. Number two, you can only add and subtract a radical if the radicals are the same. In this way, they kind of work like variables. The way that you can only add things if they have the same variables. An x only adds with another x. A y only adds with another y. Likewise, a radical 2 can only add with another radical 2. A radical 3 can only add with another radical 3. Have to have the same radicals. So let's take a look at a couple of examples really quick. Make sure we understand what we mean by that. So let's say I've got 3 radical 5 plus 8 radical 5 plus 4 radical 3. So the only ones that have the same radicals right now are the radical 5 and the radical 5. Since this one has a different radical, I cannot add this one with the others. So I can only add these two right now. When I'm adding them together, I don't add the numbers on the inside. I'm not going to add the 5s. That's going to stay the same. That's just going to say radical 5. All I add are the numbers on the outsides. 3 plus 8 makes 11. And then plus 4 radical 3. And this would be the final answer right here. I can't simplify this any further because as long as the radicals are different, you cannot add them together. So 11 radical 5 plus 4 radical 3 would be my final answer. Let's take a look at another really quick. And I'm going to erase this because you should have already written down the rules. Let's say I have 6 radical 3 minus radical 3. All right. Well, in the event there is no number in the front here, we assume the number's a 1. So as long as these radicals are the same, I can subtract. So this is going to be 6 minus 1. So this is going to give me 5 radical 3. Try not to forget that if there's no number in front of the radical, we can assume there's a 1 there. Now, likewise, something similar. Let's say, as another example, let's say I've got something like 4 radical 7 minus 4 radical 7. All right. Basic rules of subtraction, you guys. I see this mistake all the time. 4 minus 4 is just 0, but that doesn't mean the answer is 0 radical 7. The answer is just 0. Whenever you subtract something from itself, the answer is just 0. So don't write 0 radical 7. That doesn't make sense. It's just 0. Now, there are going to be times when you're adding and subtracting where you're going to need to simplify first, because sometimes in the beginning, it might not look like there is anything that can be added or subtracted, but after simplifying, you realize, there was. Now, remember I said before, you need to get used to recognizing when numbers have perfect squares inside them. Whenever you see a number that can be divided by 4, divided by 9, it should automatically go off. There's a perfect square inside there. You should, in time, get used to recognizing the other ones also. If you see something that can be divided by 25. Some of the other numbers are based off of 4s and 9s. That's why I don't worry too much about that. What I mean by it is this. Obviously, there's a little side note. So if I'm looking at my perfect squares again, 16, 25, 36, 49, 64. All right. As long as you recognize when numbers are divisible by 4 and 9, you don't have to worry about all of the other ones. Some of them, yes, 25 and 49. Let's look at like 16. if something can be divided by 16, well, it can also be divided by 4, at which point you would start taking it apart in pieces anyways. And so if something can be divided by 36, that means it can also be divided by 9 and 4. So example, if I see the number, well, I was gonna use 36 as an example, but 32. Maybe I don't recognize that 32 is divisible by 16, but you should quickly see, 32 is divisible by 4. And so again, any of these numbers here that are made up of 4 and 9, you might not recognize quickly that something's divisible by 36. Take the number 72. You might not look at this and automatically see, 72 is divisible by 36. But you should recognize that 72 is divisible by 9. And so as long as you can recognize when numbers are divisible by 4 and 9, that helps you take care of most of your perfect squares, even if you got to do it in pieces like 72. If you took out the 9 first, you would still have another perfect square left on the inside. But that's fine, because after taking out the 9, you end up with a smaller number, and then it's easier to see what the perfect square is inside that smaller number. So try to get used to recognizing whenever a number is divisible by 4 or 9, you got a perfect square in there, take it out. So here I do have a perfect square, it's inside the 8. Where to put my red marker at? Here it is. So this guy here would be 4 times 2. Square root of 4 is just 2. So this guy's coming out as a 2. So now 2 times 7 is going to be 14. So I'm going to get 14 radical 2. So we got the 2 stuck on the inside now. And I have plus 5 radical 2. Now I can see that the radicals are the same. And if the radicals are the same, I can add them up. 14 plus 5 is going to make 19. So this makes 19 radical 2. Go another one here, hold on. So if I have 5 radical 12 plus 2 radical 5 minus 3 radical 3. All right, so glancing through my radicals really quick, there is a perfect square here. See the 12? Remember, it can be divided by 4. So since this is divisible by 4, there is a perfect square inside there. There is no perfect square here, and there is no perfect square here. So this is the only one I got to take out. So this guy would be 4 and 3. 4 is the perfect square, comes out as a 2. So this is going to give me 10 radical 3 plus 2 radical 5 minus 3 radical 3. So now I can see that I have a radical here and here that are the same. So I can combine this with this. So 10 minus 3 is going to make 7. So I'm going to get 7 radical 3 plus 2 radical 5. And then after that, that's as far as it can go. It can't be simplified any further. One more together, and then you guys are going to do a couple on your own. So let's say I've got, let's say 3 radical 16 plus 2 radical 7 minus 3 radical 28 plus radical 25. Okay, so none of my radicals are the same yet. So let's start to simplify if we can. Remember, don't assume you can always simplify. Sometimes you can't, but if you can, you need to. Radical 16, 16 is a perfect square. Now I'm going to give you guys this a lot because I want you guys to get used to recognizing not that a number has a perfect square in it, although I want you to recognize that also, but when a number just is a perfect square. So this just comes out as a 4. There's no radical left. This is just going to be 3 times 4. So this is just going to give me 12. There is no perfect square over here, so this is just going to be 2 radical 7. Inside the 28, 28 is divisible by 4. So there is a perfect square inside here. This is 4 and 7. This guy comes out as a 2. So I'm going to get 2 times 3. So this is going to make 6 radical 7. And then over here, 25. 25 is a perfect square. Square root of 25 is just 5 plus 5. So now my 12 and my 5 I can combine. So 12 plus 5 is going to make 17. So I get 17. And then radical 7 and radical 7. So this is going to be 2 minus 6. I get -4 radical 7. And that's as far as it's going to go. And it is considered proper. Put your radical terms last. You could have wrote the answer like this: -4 radical 7 plus 17. These are the same thing, but we just consider it to be proper to have the radical term in the back. All right, let me put one on the board here. You guys do this one on your own. So as soon as I put it on the board, hit pause, and then try it by yourself. So if I have 5 radical 4 minus radical 3 plus 7 radical 12. Give it a shot on your own first. All right, so we should have gone through and simplified our radicals first. So here, radical 4 is a perfect square. Square root of 4 is just 2. So this is just 5 times 2. So this guy here gives me 10. Nothing to simplify here, so minus radical 3. And then over here, 12 has a perfect square inside it. Since this can be divided by 4, this guy's going to make 4 and 3. I can take out the 4, and the 4 comes out as a 2. So this gives me 2 times 7, which is going to make 14. And I still have the 3 left over inside. So now I can see that these guys here can be combined together. Remember, there's no number in the front, but if there's no number in the front, we assume the number is a 1. So this is -1 plus 14. So my answer will be 10 plus 13 radical 3. One more, and then you guys can get started on your assignment. So if I have 2 radical 18 plus 3 radical 64 minus 5 radical 3 plus radical 49. Again, pause it for a second, try it on your own, and then we'll solve it together. All right, so run through, let's simplify radicals first. I look at my first number here, 18. 18 can be divided by 9. So I got to take out the 9. So if this is 9 times 2, this guy comes out as a 3. So that's going to give me 6 radical 2. Next one, 64. Hopefully we recognize 64 is a perfect square. Square root of 64 is just 8. So this is 3 times 8. So that's going to make 24. No perfect square here, so this is just minus 5 radical 3. And then over here, square root of 49. Square root of 49 is just 7. So plus 7. So I can do my whole numbers first. So 24 plus 7. 24 plus 7 is going to make 31. And now I can't do anything with the 2 radicals. My radicals are different. So there's nothing to combine there. So this is just going to be plus 6 radical 2 minus 5 radical 3. You could have had the order of these changed around, and it doesn't matter. As long as in the end you had a positive 31, a positive 6 radical 2, and a negative 5 radical 3, that is the correct answer. It cannot be simplified any further. Now, before you start your assignment here, let me explain something about homework. From now on, your assignments are going to be turned in the next day. You have until the next morning at 8 o'clock to have them turned in, and I will consider them on time. As long as it's on time, it's worth 100%. If it's 1 day late, it goes down to 80%. 2 days late is automatic. Anything more than 2 days late is 50%. By Saturday, all right? By Saturday night, they have to be done, because on Sunday, I'm going to start using Sundays to check. Before I wasn't. Before I was giving you guys until Sunday night to turn them in.